Today we are going to start digital image processing class. Shongita Roy, Assistant Professor, Electronics and Communication Engineering Department, Narula Institute of Technology. Content: Digital image restoration, application and importance of digital image restoration. Digital image restoration. As in image enhancement, the principal goal of restoration technique is to improve an image in some predefined sense. Although there are areas of overlap, image enhancement is largely a subjective process, while image restoration is for the most part an objective process. Restoration attempts to recover an image that has been degraded by using a prior knowledge of the degradation phenomenon. Thus, restoring techniques are oriented towards modeling the degradation and applying the inverse process in order to recover the original image. This approach usually involving formulating a criteria of goodness that will yield an optimal estimate of the desired result. By contrast, enhancement techniques basically are heuristic procedures designed to manipulate an image in order to take advantage of the psychological aspects of the human visual system. For example, contrast stretching is considered an enhancement technique because it is based primarily on the pleasing aspects it might present to the viewer, whereas removal of image blur by applying a deblurring function is considered a restoration technique. Application of digital image restoration: character recognition, astronomy, dehazzing, super resolution, face recognition, biomedical image processing, artifact removal from image, image imprinting, and so on. Numerous applications are there. Importance of digital image restoration. The purpose of digital image restoration is to compensate for or undo defects which degrade an image. Degradation comes in many forms such as motion blur, noise, and camera misfocus. In case like motion blur, it is possible to come up with a very good estimate of the actual blurring function and undo the blur to restore the original image. In cases where the image is corrupted by noise, the best we may hope to do is to compensate for the degradation is caused. Now this is a degradation process. So this is a degradation process. So this is a degraded image, and this is the path from, say, transmitter to receiver, or from one place to another image is transported. So at the final side we are getting this image. So this is the image what we are getting, and this is the image what we are getting after this process. And after this we want to recover the original image. Therefore, at the time of transmission, the original image may be degraded, or another form of any change may occur in the image. So we want to get back the image in the original form. Now, what is the exact operation it is doing? That is very complex, and sometimes we cannot define exact process, but we can only model that. But exact thing we cannot model. But as close as possible, we will try to model that. Now, what is the difference between image enhancement and image restoration? Already we have studied this, but still the basic thing is, like in image enhancement we can say beautification, whereas image restoration is to get back the exact shape, exact borders. Sometimes at the time of beautification we may lose some important structure information, but in case of image restoration this structure information is recovered as close as the original. This is the difference between enhancement and restoration. Now, this is a model, image degradation model. This is one function. Say this is our original image, good quality image. So it is transmitted through a channel. As it is passes through the channel, it will be degraded. So this degradation function is defined by h, that is unknown. At the time of transmission, this image is associated with the additive noise. This is noise. So at the output, we are getting the image that is GXY. After some restoration process, we are getting F approximation XY. But FXY is not F approximation XY. This is the approximation of the original image. So as close as possible, this approximation should be, so that good quality image is restored. So this first portion is the degradation and the second portion is the restoration. Now, this is a special domain degradation equation. GXY is the degraded image, that is equal to the transfer function of the degraded convolution with the original image plus additive noise. So this is the second portion. This is the equation of the frequency domain representation. GUV is equal to HUV. Now in the time domain it is convolution, in the frequency domain it is multiplication. This is the advantage. So it is FUV plus NUV. Now the noise models. So as we have seen, there is additive noise. So this is nothing but modeling. So when we are modeling additive noise, we have to model the noise. What type of noise it is? Everything is approximation. So we have to give the idea of the noise. Unless and until we give the idea of noise, we cannot recover the original approximation of the original image. So there should be some model, standard models that we have to study in the next classes. Now spatial and frequency property of noise. Now as we have seen here, this is the equation of spatial domain degraded equation and this is the frequency domain degraded equation. Obviously this is the time domain or spatial domain noise modeling and this is the frequency domain modeling. And noise is in the spatial domain in random in nature, but when it is in frequency domain, we can see, as already we have started Fourier transform, we can separate the noise frequency and the normal image frequency, because in general noises affect in the high frequency region, and if it is, and this frequency are sporous, means they are isolated point. So if we can analyze this, the frequency spectrum, then it will be shown in a separate, in the isolated frequency in general. But I am not telling that it is the fixed. If it is a isolated frequency spectrum is there, that is noise. It is not that, but in general it has been found that frequency are as isolated frequencies, whereas normal pixels are in groups. These are the references, and thank you.